Okay, so for number 10, the first thing that you want to notice is that there is this infinity. So it's going to come back to us, and we're going to do something about this. But the first thing I would do is I would notice is that there's an x squared in both terms, so I would factor it out, and it would look like this. Okay, so now this is the 1 minus cosine that we have seen before. Now this would be an example where a u substitution is needed, and you know that because usually, remember when we use this theorem, the sine of x over x, its limit as x goes to 0. So when you don't see this being 0, that's how you know that you would probably need a u substitution. So what we're going to do is, whatever the angle is, the expression for the angle is, we're going to make that a u. So we're going to say let u be equal to 1 over x. Now let's think about this. Since x is approaching infinity, you would be approaching 0 because you would have 1 over infinity here. So we are going to rewrite this. We're going to change, instead of x being approaching infinity, we're going to make it u approaching 0 so that we can use our theorem. X squared is really going to be like 1 over x squared. So that's really 1 over u squared. And then we have 1 minus cosine of u. And we're going to deal with this by multiplying top and bottom by 1 plus cosine of u. So limit as u approaches 0, we have 1 minus cosine of u, 1 plus cosine of u, over u squared, and then we have the same 1 plus cosine of u. So this turned into sine squared of u on the top. Over u squared, and then I'm going to leave this as one expression, and then I'm going to move over 1 plus cosine of u. Okay, so now that we have u approaching 0, we have sine of u over u, now we can say that this limit is going to go to 1, and then my answer is going to be whatever I get by substituting 0 for u of the leftover expression. So cosine of 0 is going to be 1, so I simply get 1 over 1 plus 1, which is 1/2.